Here's a quick tutorial on showing your work to input an x value, do some substitution, and get a y value, which we can later graph and do some other things with. Problem GC 112, here are the directions. It says, and I quote, "Copy this table and use the order of operations to complete it. Using the example given as a model, show all of your work for each y value." So I've copied down the table like it asked me to, and this is the example given in the book. I start with a -2 for an x value. I've got this equation right here. What I need to do is substitute the -2 everywhere I see an x, and then perform the calculations to arrive at the y value, and then put the y value over here on the far right. The example also shows circling the terms, which we've practiced in class. Once again, terms are separated by addition or subtraction signs. It's another way for us to show the order of operations. So since we have this example to look at, let's just do the same exact thing, but use -1 instead of -2. So we start with y equals, instead of the x, I'm going to write the -1 squared plus 2 times -1. Once again, looking up here, I had 2 times -2 this first time. So since we're using -1 now, I use that instead. And of course the 1, that's a constant. That stays the same. It's always 1, no matter what x turns into. I'm going to circle the terms just like in the example. That's why examples are great. All you need to do is basically do the same thing. Now I'm going to do the work inside each circle. -1 times -1 is 1. Remember, 2 negatives equals a positive when multiplying. Then 2 -1s is -2. And then the 1, of course, stays the same. I show that I'm aware that these are still terms, even though they're been simplified now. I just do the math. I have 2 positives and I have 2 negatives. It looks like they cancel each other out to 0, and I put the value over here. So when I input a -1, substitution to get the solution is 0 for the y value. I could then graph that, right? If I had a graph over here, I'll just make a quick one. And for this one, my ordered pair would be -1 and 0. I would start at the origin. I'd go backwards or to the left 1. And the 0, I would not go up or down. I could graph that right there. Okay, so we could graph these points. Let me do one more example for you. The book wants you to perform this operation with a 0. Y equals 0 squared and 2 times 0 plus 1. Why didn't I change the 1? Well, that's a constant, right? That does not change. Has nothing to do with the x value, which did change. So all I do is look for the x in the original equation, and I put the 0 in there, substitute. When I have nothing and I multiply it by nothing, hopefully my answer is still nothing. If I have no 2's, that means I have nothing, and I have the 1 there. I can circle the terms, just to show that I'm aware that there are still terms here, right? We can practice circling the terms even if it seems like this is something real easy you can just do mentally. Okay, it's good to practice all the time. That gives us a 1. So I'm going to come over here to the y value, put a 1 in, bring my lines down. There we go. How about one more example? Does that sound like fun? It does to me, because once I do an example and I repeat it a couple times with something else, I notice that it gets easier and easier every time. So we have one more example, and I have room on my page to fit that in. Y equals, this time it's 1 squared, because that's where the x was, plus 2 times x. X is 1 now, and the 1 is a constant. That stays the same. Circle the terms. Do the work. 1 times 1 is 1. 2 times 1 is 2. And then our constant 1 stays the same. Perform the calculation. I get a 4, and I take that value over to my y column for 4. If I asked you to graph this, you would have an ordered pair, the x value and the y value. And on a graph here, that means I'd go to the origin, take my x value, I'd go over 1, and up 4 for the y value. I could graph that right there. Okay? I hope that helps you fill in these tables, and I'll see you in class. Bye.